Hi everyone, welcome to Daily Data Engineering Shorts. So today we are going to cover about the acid properties. So in last episodes we have covered the border delta lake and we heard this particular term acid transaction. So what are these? So basically acid transactions are fundamental operations that allow us to modify and retrieve data. But however, to ensure the integrity of a database, it is important that these transactions are executed in a way that maintains the consistency, correctness, and reliability. So even in the case of failure or some error is coming, so this is where the acid properties comes into play. So if acid is the basically the acronym for the atomicity, consistency, isolation, and the durability. So if you talk about the atomicity, it means a transaction is all or nothing. Either all its operations succeed or none are applied. So like if any part fails, the entire transaction is rolled back to keep the database consistent. So if the transaction is successful, the changes are permanently applied. If transaction fails, any changes made during the transaction are discarded. Coming for the consistency, so in transaction it means that the database must remain in a valid state before and after the transaction. So let's suppose a valid state follows all defined rules, constraints, and relationship like primary and foreign key in a table. So if a transaction violates any of these rules, it is rolled back to the prevent it roll back to prevent the corrupt and invalid data. So just for an example, if a transaction deducts money from one bank account but does not add it to the another, it violates the consistency. Then the isolation part. Isolation basically ensures the transaction run independently without affecting each other. Changes made by one transaction are not visual to the others until they are committed. So basically it ensures the result of the concurrent transaction is the same as if they were run one after another. Prevents the issues like uncommitted data changes between two reads like this. Then comes the durability. So basically it ensures that once a transaction is committed, its changes are permanently saved even if the system fails. So that data is basically stored in the non-volatile memory. So the database can recover to its last committed state without losing the data. So just for an example, after successfully transferring money from account A to account B, the changes are stored in the disk. So even if there is a crash immediately after the commit, the transfer details will still be intact when the system recovers, and it ensures the durability in that way. So that's it in the today's episode. We'll cover the next topic soon. If you like the content, like, share, subscribe. Thank you.